Let's begin with introduction. So what is differentiation? Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. If x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. This is the general expression of the derivative of a function and is represented as f prime x equals to dy over dx, where y equals to fx is any function.
Next, type of technique of differentiation. First, power rule, used to differentiate power of x. Second, quotient rule, applied when one function is divided by another. Third, constant rule, the derivative of a constant is zero. Fourth, product rule, applied when two functions are multiplied. 5. Chain rule, used when a function is inside another function. Trigonometric rule, for differentiate sine, cosine, tangent, and other trigonometric function. 7. Exponential rule, for differentiating exponential function. 8. Generalized power rule, an extension of the power rule when the base is a function. Lastly, logarithm rule, for differentiating logarithmic function.
Question 2a. Find the dy per dx for y equal to e to the power 2x squared multiplied by 2, open bracket, 3x cubed minus x plus 2, close bracket. For this question, we will be using product rule. Firstly, you need to separate an exponential u and a polynomial v. Here, we got u as e to the power 2x squared to multiply by 2, and v as a 3x cubed minus x plus 2, close bracket. Then, with derivative to get u and v prime using chain rule. For product rule, we will be using formula dy per dx equals to uv prime plus vu prime. After that, you put the u, v, u prime, and v prime based on the formula. Next, you need to separate the e to the power 2x squared multiplied by 2, leaving the number 4 in bracket. After that, you solve the equation inside the bracket. 4x times 3x cubed, 4x times negative x, and 4x times 2. After that, you just simply solve the equation inside the bracket. And finally, you will get the final answer. The answer is dy per dx equals to e to the power 2x squared 2 multiplied by 2 in bracket 12x to the power of 4 plus 5x squared plus 8x minus 1, close bracket. Dy over dx for y equals to ln sine 3x over 3 minus x cubed. Here we are applying quotient rule, which is dy over dx equals to vu prime minus uv prime over v squared. Starting by listing down u equals to ln sine 3x and v equals to 3 minus x cubed. First step, differentiate u. Du over dx equals to ln 1 over sine 3x times d over dx sine 3x equals to 1 over sine 3x times cos 3x times 3 equals to 3 cos 3x over sine 3x. Here, we are using properties of trigo. Therefore, cos over sine equals to cot. Therefore, 3 cos 3x over sine 3x equals to 3 cot 3x. Next step, differentiate v. dv over dx equals to d over dx 3 minus x cubed equals to negative 3x squared. And lastly, differentiate the whole thing. 3 cot 3x times 3 minus x cubed minus ln sine 3x times negative 3x squared over 3 minus x cubed squared. Bear in mind, we don't expand denominators. Equals to 9 cot 3x minus 3x cubed cot 3x plus 3x squared ln sine 3x over 3 minus x cubed squared. The final answer would be 3 cot 3x
times 3 minus x cubed plus 3x squared ln sine 3x over 3 minus x cubed squared.
Given y ln 2x minus e power of 3x minus 7 minus 7 for y equal to 2x power of 2 minus 9. Find dy over dx using implicit differentiation. First, we need to put d over dx each of them. For y ln 2x, we need to differentiate them using product rule, which is y equal to u and v equal to ln 2x. So, for u prime, it will become 1 dy over dx. If we want to differentiate y, we need to put dy over dx. For v prime, it will become 1 over 2x. So using the product rule, uv prime plus vu prime, it will become y over x plus ln 2x dy dx. Next, e power of 3x minus 7, if you want to differentiate them, we need to using chain rule exponential. So it will become 3e power of 3x minus 7. For sine for y, we need to use sine term, which is sine is equal to cos. So, for cos for y dy over dx. Next, 2x power of 2. If we differentiate them, it will become 4x using power rule. For d over dx 9, it will become 0 because we are using constant rule. After we differentiate them, we need to categorize them in one group, also factorize them. So it will become ln 2x dy over dx minus 4 cos power y dy over dx equal to 4x plus 3 e power of 3x minus 7 minus y over x. So we need to expand x because we already have 3 fractions. So we want to use only 2 fractions. So if we categorize them, it will become dy over dx and bracket ln 2x minus 4 cos power y bracket equal to 4x power of 2 plus 3x e power of 3x minus 7 minus y over x. Next, we put dy over dx lastly equal to 4x power of 2 plus 3x e power of 3x minus 7 minus y over x in bracket ln 2x minus 4 cos 4y bracket. So that is the last answer.
Okay, now we move to the last question. At first, we need to apply the 4.02 as x. So it will be fx equal to x power of 2 minus ln x. And then we will differentiate it and it will become f prime x equals to 2x minus 1 over x. For the next steps, we want to find the delta x, so we subtract the x naught from x. The value of x naught is the closest integer to the 4.02, which is 4. And the answer we will get 0.02. Lastly, we will apply the linear approximation formula, that is f naught fx naught plus f prime x naught multiply delta x. The equation will be x power of 2 minus ln x plus in bracket 2 multiply 4 minus 1 over 4 times 0.02. And the final answer we will get 14.069. The conclusion is the technique of differentiation is fundamental concept in calculus used to determine the instantaneous rate of change of a function. Mastering the various techniques allows for the analysis of function behavior, which has broad application across science, engineering, and economics.